What's up? My name's Jesse. I am a technical recruiter, most recently at Replit. Unfortunately, was caught in the 25% reduction that happened last Thursday. And so basically, I guess, unshamed plug first. If you are a startup and you need help hiring technical talent, the more technical or the more niche the skill set, the more fun for me. So if you need help with that, I'm here. But I'm just going to go ahead and show you that in fact I do code a little bit. I'm going to solve, I think it's a daily question from 2 or 3 days ago. I haven't actually looked at it yet, but I had it pulled up, and so I thought I'd go ahead and solve it. People have opinions about LeetCode. I have my own opinions about LeetCode, which, I think for better or worse, algorithmic problems are, especially in the format of this, probably are not super reflective of normal day in the life of work as a software engineer, but is kind of an unfortunate reality that assessing technical skills is hard, and doing that in a way that doesn't cost a crap load of time is also hard. So I wanted to basically put this out here. I was going to do it anyway, so why not share it, right? So here we go. Let me move this thing so I can read. Okay, how do I minimize this? I want to be able to read. There we go. Okay. So delete leaves with a given value. Given a binary tree root and an integer target, delete all the leaf nodes with value target. Note that once you delete a leaf node with value target, if its parent node becomes a leaf node and has the value target, it should also be deleted. You need to continue doing that until you cannot. Okay, so basically all the left leaves here, all the left leaves equal the target, so you get rid of all of those and you're left with just kind of the right side of the tree. Okay, so I think maybe we can start out thinking about just like the simplest possible shape that this thing could be. Let's say our tree 1 has no children and that the target equals 1. In this case, we visit, so when the function gets called, I guess actually the simplest thing is our tree might be none. So like we might just get something in the case that we don't actually get a node. We're just going to return that, I believe. I think and I suspect it would actually just be this, possibly. See, no output is null. So interesting. Okay, all right. So in the case of tree equals 1 and target equals 1, when the function gets called, we are at the node that has a target value and there are no children. So basically we need to check if node is leaf, check if node val equals target. If so, delete node, and then return root, I guess. Yeah. There are going to be some funky cases where, like, there could be a funky case where you have the tree, like, let's say you have 1, the left child is 2, the right child is 3, and the target equals 1. So just to show that, it'd be, let's see, 1. something like that. So in the case that you have something like this, do you have to rotate? Let's see. It doesn't clarify. Oh, yeah, but it doesn't matter because that's not a leaf. Okay, yeah, okay, cool. So that's actually not hard, that's trivial. Okay, so it being a leaf is gonna be a big deal. So what I'm thinking is the first thing you have to do is traverse, because you gotta get to the edges. So we're doing a depth first search. So if we do depth first, then you get out to the leaves. At the leaves, you're gonna basically the whole way down, you're just basically trying to see if the node that you're on is a leaf or not. And only in the case that it is a leaf do you then check for equality with target. If equality, delete it, otherwise don't. And then do you actually have to do any, you don't really need to return anything. I am curious about the case where, let me just say this out loud, and then we can keep thinking about kind of what happens sequentially. So say you have a tree that is 1, and then 2, and then 3, and then 4, and everything's right. So everything's right facing. So then your target being 1 tar. So in this case, I'm thinking, okay, cool. This is, I don't understand why this is a medium, because I guess what I was thinking in my head was like, oh, well, one is your node and it equals the target. So then what do you do in the case of like having to reattach other ones? But like it being leaves makes this conceivably should be pretty easy. So let's think about this. So I can't remember, is delete a keyword or is it del? It's del. Okay, so is it? Let's see. Delete objects. Okay. So then the thing that we have to do first, though, is we have to go out, right? So if you've got a tree where everything is a leaf, like, or everything equals the target, so then you have like a whole bunch of 1s and the target is 1. So then you're going to go out to the bottom layer of the tree. You're going to delete all those. Then you're going to check if those all equal 1, and they do. So then you delete those, and you go up to the top, you delete that. Okay, should be pretty straightforward. So if what I'm thinking is we have to traverse first, right? So we have to traverse first. So if root.left remove self.remove leaf nodes root.left target if root.right self.remove leaf nodes root.right target. So this should, I mean, that by itself should get us out, right? That should traverse us out to the leaves. So then if root dot left, if root dot right, so then we're at leaves now. If root dot val equals target. This is a tough one. If root dot val, yep, if root dot val equals target, now can you, so yeah, send, I think you would just delete root and then you would return because I don't really want to I just want to mutate this thing. I don't really want to make a copy of it and then like return the whole thing, because then we're using up a whole bunch of memory that we don't really have to. So yeah, to the leaf. We do those two things. So if we get to this point, if we get to 29, has to be a leaf. Okay. Because no children. So then if root.val equals target, then we're going to delete root. To delete leaf node. So then from there, so I'm just thinking, okay, you get down to the bottom. I'm just thinking, do these changes propagate back up? Because, yeah, because then if you have root dot left, boop, boop, boop. If root dot right, boop, boop, boop. If not, do I need to explicitly say that? Because I'm thinking you do need to explicitly say, if not left and not right after you go down, because one could become a leaf. So a node that you traversed kind of past in the first sweep, or kind of in the downward sweep, after deletion of its leaf nodes, could become a leaf itself. So then you kind of need to recheck at the level that you're at if it's a leaf. So if not root dot left and not root dot right and delete root. So then here's the question. So then what do you return? I think you just return root. Because in the case that you delete the whole tree, you are returning none, or you should be, I think. They don't show that one, right? So they show this one, which is pretty close. Let's give this a shot, because I think we're pretty much there, right? Because the thing is, what we're doing is we're traversing first. If we have the left side, return, well, do we need to return that? No, we just do it, right? We don't need to return it. We're just calling on the left side. So then that's like that sub function call. So then however many lefts we've got, we're going down the left. So if we go way down the left and then it has a right child, let's say the target's 1, and we're going the whole way down, a whole bunch of 1s, and then there's a right child at the very bottom of kind of that left branch, then we go there. If it's a 1, okay, we delete it. Now we have a whole bunch of 1s chaining up to the top. So then 1, you delete that, delete that, delete that, delete that, up to the root, the initial root node. So if root.left, so basically we're just going down the tree as far as there is left. And if there are rights, we're visiting those as well. Let's see. Now, as far as the right is concerned, am I doing this correctly? So if root.right, you go to something that is right, and then it has a bunch of lefts, you're still getting, so you're still traversing down to the bottom. So you have to visit leaves. So then if not root.left, so then you visited those leaves. So you hit the leaf. This feels duplicative, but I think you have to say this. So like, if root val equals target, so now down here you have hit a leaf. But you shouldn't, in the case that everything that you have, you have to say this exactly for this case. Well, okay, maybe not for this case, right? But so if we have an example like example 3 here, where if we have an example like 3, where we have let's say we have something like that, and target equals 1, right? So then we go down, we start here. Is there root.left? Yes. Do this on this one. Is there root.left? Yes. We're just going to show the whole functionality here. So is there root.left? Yes. We get down to this one. We're making this call on this one. So then we get that. Is there a root.left? No. Is there a root.right? Yes. Okay, so then we go to that one. We do this call again. Is there root.left? No. Is there root.right? No. If it doesn't have root.left and root.right, then delete this, right? We don't need to return anything. We just need to get rid of it. So then we're back here. We just checked if it's root.right. If it doesn't have left and it doesn't have right, then we need to delete this. Does it have right? We were at this point here. Does it have root.right? No, it does not. So then we will look at, does it have right? No, it does not. If it doesn't have root.left and it doesn't have root.right, then delete, right? Doesn't have right? No. Doesn't have left and does not have right. Root val equals target, boom, right? So then we should, I believe this is it, right? But we don't need to do, I don't think we need to copy the tree. We don't need to do anything. We can delete objects in place, basically. I believe this is right. So let's give it a good old try. Cannot access root or is not associated with a value. Let's see, return root. Okay, so in the case that it got deleted, 2. How is it not associated with a value here? Damn, am I gonna have to construct this tree? That would be such a bummer if I have to do that. Can I say else? Ooh, cool, so we're wrong. So I kept all my 2's around. Okay, let's do this. Print self visiting. Okay, let's run that again. So we're visiting 1. This is just this one, right? Yeah, is that first test kit? Yeah, okay, cool. So we're visiting 1, we visit 2, we visit 2. This is expected. Let's do this. So we're never, oh, okay, deleting 2. Okay, visiting, deleting 2. So we get down to this 2, and we delete it. It says visiting 3. Do I have to return these? Interesting, now I'm deleting everything. But here, okay. Oh, wait, okay. There we go, got it. And now I don't need this if statement, I believe. Cool. All right. Yeah, so I realized I didn't say a word right there. But basically, what we were doing that was kind of problematic before was we were just calling this on the node. I wonder why delete didn't do what I wanted it to do. I'm not quite sure. I might make another video explaining what the hell, because I'm gonna have to do some like tinkering around to figure out why. Because basically the issue is, well, if I say, what if I said L root? So then does that break? Yeah, but then I guess if I would bet if I say else, that works. Yeah, so it's this assignment thing that makes it weird. That's interesting. Man, do they have Vim key bindings on here? But yeah, so I mean, I think the thing that I'm a little torn up about is this like kind of reassignment thing. But I don't think you're not actually utilizing any extra space here. Nice. Let's look at case 3. Yeah, look at that. Nice. Yeah. So, I mean, I will say, I mean, like at face value, I don't think this is a hard problem. It doesn't feel like a hard problem, at least. Let's submit and see if I break anything. There we go. Dope. Okay. Kind of slow. Oh, I'm printing. A fucking idiot. Okay. Submit again. That should be a bit better. I don't understand. Oh, okay. This is such a silly thing. Is like, I do this and I shouldn't care. I almost wonder if you even have to do this validity check. Like, do you have to do... Untype, yeah. Yeah, that makes sense. Yeah, because you can't. Yeah, that makes sense. Recognize that I'm doing a absolute shit job of explaining what's going on here. So basically what we're doing is we are traversing down to the bottom. We're doing a depth first search. We're going down to the leaves. And then as we visit, basically like we're saying if root.left, then reassign root.left whatever the resulting thing from this function call on that node is. And it could either be none or it could be what it was. And it just depends on whether or not the root val equals the target. I am almost certain, I do want to double check one thing real quick. I am almost certain you have to have, yes, okay, cool. So you do have to have that kind of redundancy at line 15 here to basically ensure that the node that you had been to previously became a leaf. And so basically you go down the left, go down the right, delete a bunch of stuff, reassign if you need to. I wonder, so let's look at that again. So it's running, kind of in a variety of spaces, but I wonder if we say delete root, that should still work. No. Yeah, God. Okay, I keep forgetting that. Else. Bob. Run. I wonder which of those are... What? Okay, why... Dude, the variability on these is freaking crazy. It's nuts to me how variable these are. I'll say just from kind of like a spiritual perspective, I think this reads a little bit better and would likely be a bit easier to maintain. There is a question that I have in my head of like, we are creating a lot of stuff on the stack, and I wonder if there's a better way of like traversing so that you're not like adding all this stuff on the stack. I'm positive that there is a way to do this iteratively as opposed to recursively. This one just, feels very straightforward and easy. But so that's it. That's all I'm gonna say. 32 minutes. I'm not too displeased. Got a bit hung up on this reassignment part right here, but I think in general, kind of straightforward. Friendly reminder: I'm looking for a job. If you need to hire technical talent, I would love to talk to you. If you don't have the ability to hire somebody full time, or you don't have the ability to hire anybody on contract or anything, I'm also down to provide technical hiring as a service too. So please don't hesitate to hit me up. I'm excited to chat with you. So thanks for watching this. Bye.